All right, what we're working on here is the learning target that says I can represent context with a table and a graph. So the context has to do with the story, and in this case, our story is just right here. This portion here is our context. So we're going to represent this situation on a graph and on a table. Okay? A family is buying small items for charity. Each item is $3.50, and they have a coupon for $2 for the entire purchase. Okay, so the important information that you have there is it's $3.50 for each item. So I'm going to make some notes there and say $3.50 per item. And they have a $2 coupon. So they've got $2 off, right? $2 off. So $2 off, and the way we see taking that away, that's $2 that we are taking away, like it's going to be $2 cheaper, so it's going to be a negative. Okay. Sorry, got distracted. Door opened. All right, so what I have here in the table is x and y, but I don't see any x and y in my context, so I have to be able to identify that. Otherwise, if I don't, I'm not representing the context because I haven't identified what x is. So what is x standing for? What is y standing for? We need to decide that. And as we look through here, it's talking about money, and it's also talking about the item. So the money is going to depend on the item. Let's say the items were a box of chocolates a piece. Okay, so it's $3.50 for a box of chocolates. You're talking about money and that item. So your money is your y, and I'm going to write item for your x. Okay, so I'm going to write up here item and total money that it's going to cost. If I have 0 items, right, how much is it going to cost me? That's what we're trying to figure out. If I have 8 items, how much is that going to cost me? Well, first thing that I can do is I can look and say, well, my $2 off, that's my y-intercept. And the way I represent a y-intercept on a table is where x is 0. So when I have 0 items, basically have $2, right? But it's going to be $3.50 for each item. So when I go up by 1 item, I am increasing this by $3.50. Okay, I'm at negative 2. I'm going to increase it by $3.50. So I'm now at $1.50 because the item was $3.50, but I had $2 off. Okay, I'm going to increase this by 4 because 1 plus 4 gives me 5. And I'm going to think about my $3.50 per item as my rate of change. And I'm going to write here that if my change of y is $3.50 for every 1 item, then I know that if I have 4 items, I have to scale up my $3.50. I'm going to take $3.50, I'm going to multiply it by 4 because I'm buying 4 of them. And so that's $14. When it's $3.50 for 1 item, well, it's $14 for 4 items. So this is going to increase by $14. $14 for 4 items. $14 is going to increase when I buy 4 more items. I'm at $1.50, add 14, and I'm now at $15.50. It's $15.50 for 5 items when I had my coupon for $2. Okay? And that's one way to do it, is continue your rate of change. Another way is to make your equation of this and then just apply it. So the equation, what we've learned, we have a toolkit on if you need to go back to that, is y equals 350x minus 2, because it's rate of change times x minus the y-intercept. Okay? Now, if my x in this case is 8, then I need to make this guy multiplied by 8 to figure out the answer or the solution for y. What I end up with is 350 times 8 minus 2, and I'm going to come up with that solution. So in my calculator, I'm going to do exactly that. and I'm going to say 350 times 8 minus 2. That is that right there, and I press enter and I get 26. Okay, 26. Here's your input, right, and it became 8. Here's your output, and it's 26. So when we buy 8 items and we have a $2 off coupon and each item was $3.50, our cost is $26. All right, so we've done the first part. I can represent the context with a table. Now we're going to represent that with a graph. Since we already have the table, we can represent it pretty easy by just modeling these points on here. Again, to be advanced proficient, you'd have to be able to label my x. It has to have a label here. What is this? This is the number of items that you're buying. And what's y standing for? That is the money it costs. I might just write here cost. Okay. My first point is 0, negative 2. So I'm going to go over 0 on the x, and I'm going to go down 2 because it's negative, right? So this is negative 1, negative 2. And there wasn't a spot, so I just made one. So sometimes we need to make things work if it's not already set up for us. Next one is 1 and 1.5 over 1 up 1.5, trying to be as precise as possible. Next is 5, 15, 50. So I've got 5 and I've got 15, 50. And the next one just gets too far out. We can't use it. But what we can do is represent this with a straight line. Okay? And what's happening here is I started here and I increased by 1, 2, 3, 50, right? Halfway up, 350 for every 1. So I could do that again and I could say 1, 2, 3, 50 for 1. 1, 2, 3, 50 for every 1. What I'm doing is this right here. $3, I'm going up $3.50 and I'm going over 1. 1, 2, 3, 50 for 1. 1, 2, 3, 50, and then it takes me back when I go over 1 to that point that I already made. And therefore I know I'm right because it worked twice. And hopefully both ways were right. I now have a straight line. It's linear. Any kind of linear graph should be straight. All right? So that is how you would model that learning target. I represented this situation on a graph and on a table. And I have a lot of work to show here. Advanced proficiency is going to look like this. Advanced proficiency is not going to look like just these little spots filled in a line. Okay? You might be able to do it, but you got to be able to show that you're doing it.